After another break, now let us discuss the importance. Are our results important, or how important are they? For this purpose, we have the parameters measured, which show the importance of the study, like relative risk, absolute risk reduction, number needed to treat, odds ratio, etc. This we all have gone through, discussed during our previous presentations. In general, larger values of relative risk or odds ratio show a greater attention, or call for greater attention. Those response also is consistent with causation. Look here. This was the study on meta-analysis on the paracetamol. The relative risk of developing hypertension on non-steroidal anti-inflammatory drugs was 1.86. And the 95% confidence interval is between 1.5 and 2.2. For paracetamol, it was 2.0 and 95% confidence interval between 1.5 and 2.6 again. What do these figures show you, considering the importance? Is this result important for you? How large is the relative risk? It is almost 2 for NSAIDs, and also for paracetamol, it is 2. And 2 times higher risk means, for me at least, clinically, it would mean something. But of course, only the relative risk or odds ratio itself is not enough. We have to look also how precise is the measurement. And if you look the confidence interval here, it is between 1.5 and 2.6. So not very bad, I would say. That is subjectively said, but it should be narrow. The confidence, the more narrow confidence interval you have, the more precise measurement you have. So our measure of precision in this case are the confidence intervals, not the p-values. The p-values also important. They show us whether it is we have an important, significant difference, but we have to look especially to the confidence interval. If a wide interval, confidence interval, that means less reliable, less precise measurements. Look at these 4 confidence intervals. Of course, you should demand or ask also for the relative risk value. Here, I haven't given you the relative risk value, but let's say for this case, it is 13, the relative risk. Here, we have a relative risk of 50. Here, we have a relative risk of 8. And here, we have a relative risk of 0.99. I'm imputing these numbers. Okay, so what would you say, considering the confidence intervals? What would you say if you look at the confidence intervals? If I have a relative risk of 13 with a confidence interval of 11 to 15, that means, is it reliable? Is it narrow? Or is it wide? It's more, I would say, it speaks for more narrow confidence interval. What about this here? Between 1 and 200, obviously it is very large. But also here, in the third example, we have a considerably large confidence interval. And in the last example, we have a very narrow confidence interval. Now, remembering our previous presentations, if you should be able to tell that P is less than 0.05 or P is significant whenever the confidence interval of the relative risk is not including 1. So what about these 4 examples? Is this including 1, this confidence interval, 11 and 15? Between these 11 and 15, we don't have 1. So this p-value is less than 0.05. What about this one? It is also less than 0.05. What about this one, 0.1 and 14? Is it including 1, this interval? Yes, it is including 1. That means the p-value is larger than 0.05. What about the last example, 0.9 and 1? There is also the 1 included. So you see the significance, although these 2 examples are significant, they have less small p-values. One has a very broad, very large confidence interval, whereas the other one is more precise measurement. On the other hand, in these 2 other examples, we have a non-significant p-values, but also here one is precise measurement. So significant and non-significant does not per se indicate whether it is precise measurement or not. Lastly, in this chapter, hazard ratio. Let us read from the slide. Regression models are used to obtain hazard ratio and their confidence intervals. So these are this is a statistical method. Using the regression models, we calculate the hazard ratios. Hazard ratio is a measure of an effect of an intervention on an outcome of interest over time. Hazard ratio is reported most commonly in time to event analysis or survival analysis. The outcome could be an adverse or negative outcome, like time from treatment, surgery until death, or a positive outcome, like time to cure or disease-free survival. Hazard ratio is the ratio of hazards, and that is equal to hazards in the intervention group divided by hazard in the control group. So that's in interpretation is very similar to the odds ratio or to the relative risk. The interventions and the interpretations are very similar. It's more stopping the recording.